Graphene is a unique nanoscale form of carbon that is disrupting legacy materials, bringing step-change improvements in performance across a wide range of industrial and consumer applications. From energy storage and electronics to everyday materials, graphene enables products that are better, stronger, and lighter, while increasing durability and improving sustainability. Graphene is leading the era of new advanced materials.
The following is a presentation that was given as part of a 2-day virtual Graphene Investors Conference, hosted by the Graphene Council.
Thank you, Terrence. So, Kirsten Brewer, President and CEO of Hydrograph Clean Power. And we can skip through the forward-looking statement. And so what do? We believe that we produce the highest quality graphene, also a turbostratic graphene, in the industry at the greatest cost efficiency. How we do this is very closely tied to our production process, which is an explosion synthesis. We effectively use hydrocarbon gases, we detonate those gases, and in that one step, using virtually no energy, we produce pristine graphene. We feel that this is the most environmentally friendly process in the world, and commercialization of this has already begun. We have been tested in more than 20 different applications, from lubricants, coatings, concrete, automotive applications, and energy storage, with very, very strong performance in each, often double-digit or triple-digit improvements with very, very low loadings. Currently, our scalable production capacity is 10 tons per year, as we can produce new units in a matter of months, not years, with very low capex. We are inherently scalable. We will have new units online by the end of this year, and we will continue to grow with customer demand. Founded in 2017, we of course have everything patented with global patents. 5 are still pending. About 16 employees, so a relatively small company, and we have 11 graphene products or graphene derivatives. So I would caveat this slide as saying this is slightly dated, so I do believe that companies have evolved beyond this, but effectively the Journal of Advanced Materials did a study on 300 companies. We were not included, this was before our time, and found that there is almost no high quality graphene in the market as defined by the ISO. They found that no company produces over 50% graphene content, with a majority producing less than 10%. And that would mean that most companies are actually producing fine graphite, not graphene. As I mentioned, I think that we have evolved beyond this as an industry. I do think that there are more companies that are producing real graphene, and certainly more consistently. But to take this back to Hydrograph, we make identical batches every single time, not only with every detonation, with every single scale up. We produce 99.8% pure carbon content graphene, and this has been tested as pure graphene by, we're past 5 labs, so I'll have to update that, and of course by the Graphene Council. I think we can gloss over this, as I think most on this call will know the benefits of graphene, but of course we're looking at very high strength, conductivity, and then of course we can continue to add and really have multiple functionalities when we're looking at improving materials. I would say just a quick note with us is because our graphene is so powerful, you can use less graphene, so it's going to have a lower loading. And this is often either at a cost break even to the customer, which is really attractive, especially when we're looking at these very large volume markets. Just a quick comment on the timeline. This was discovered at Kansas State University in 2014 by Dr. Chris Sorensen. This was patented shortly thereafter. What was then called Carbon 2D was formed in 2017 to commercialize this technology. And now we've really gone from an R&D focused company to a more commercial operation. We have our production units producing graphene consistently within the US. We are a Canadian public company. And now more recently in this past year, we have operations in Manchester, the home of graphene, where we have an application lab at the GEEK, which is the Graphene Engineering Innovation Center that is affiliated with Manchester University. And that's where a lot of customers come when they want to start integrating graphene, and there's a lot of material scientists and expertise around the industry. Our strategy. Effectively, we have been working on producing pristine graphene at industrial scale, which we feel we do very, very well. We produce consistent graphene, and it's extremely scalable. at a very attractive price to the customer. We will have a centralized production model. We will maintain all of our IP in-house. The most important thing for us is an ease of supply to acetylene, because gas is much more difficult to store, compress, transport, as opposed to graphene. We feel this model suits us best. We will, of course, as we grow, have regional production when it suits the customer. And beyond this, as many graphene companies are doing as well, we will continue to expand and look at formulation and master batch processing, which is critical, I believe, in thermoplastic and other instances where really what we do, of course, we make this high quality graphene material, but helping the customer to integrate that is also of a primary importance to the company. So we'll always include these capabilities as well. This is a lot of text, so we're not going to go through everything, but this is an overview of what we've been working on. We have very strong results with lubricants. We can decrease the coefficient of friction by more than 70%. We're adding anti-corrosion properties. There's a great thermal transfer that's taking place here. We have done work within composites. We can increase electrical conductivity in epoxies. We can improve thermal conductivity. One of the defining features of Hydrograph materials, we're extremely conductive. We're very comfortable with achieving double-digit strength improvements in compressive, flexural strength across the board with different materials. And this, again, is at very, very low loading. So this is something that we're still working on. We're constantly refining. We're constantly looking at new markets within this space. What is newer to us is coatings. We actually have triple-digit performance improvements that we will be disclosing shortly. And again, with very low loadings, and now looking at the increased functionalities that we can provide, whether it's UV resistance, anti-corrosion properties, and more. Concrete, again, we can get to about 30% increase in compressive strength with only 0.03 graphene added. So this does work out to a cost break even for concrete companies, which I would stress is a difficult thing to achieve. Graphene has to not only be extremely powerful, but it has to be at the right price to enter these markets that are very tight margins and, of course, massive, massive volumes. And of course, with our scalability, we will be able to actually move forward with a lot of these opportunities. And then lastly, we've done work in energy storage. We have a 47% increase in charge acceptance in lead acid batteries. We have done work with lithium air, lithium ion, zinc ion. In every situation where we have tested our graphene, we have had results that surpass expectations, not only from people that have used graphene before, but to be very honest, also our own. So we are very pleased with the performance that we have seen. We work not only with energy storage, but composites. And this is what we're now coming to understand relatively unique in the industry, that we have this amount of flexibility as we tackle these application areas. So just to touch on where we're at, we are currently targeting composites, coatings, and batteries. This is where we have very strong performance, and this is where we have data to support our activity. We will continue to look at other markets. We'll look at concrete, lubricants, biosensors, and there's many, many more. To tackle the secondary markets, we're going to need partners. So what we're doing when we're looking at our own activities, we have an application lab at the Geek in Manchester that I've touched on, and you can ignore all this text to the right. It's quite a lot. But I think it's worth pointing out that Manchester is still really a hot spot for graphene and graphene research. There are many graphene companies that have located there, and there are many customers globally that come when they want to start integrating graphene into their products. So this team, we have a Hydrograph team that has a lab within the center, but there's also the Geek team. And so when they get requests at the Geek to start integrating graphene, they need to be unbiased and give the customer the best performing graphene, which at that point would be anonymous. There would be a study conducted to see how it's performing. And then if the results are successful, the company then gets connected to the graphene producer. And this is a model that we have thus far, we've only been there since January, performed very, very well. And so we are engaged in multiple projects with Geek customers that have come looking for different improvements to their materials, and we believe that we will be able to announce something within the next few months regarding this activity. And so our production process is extremely unique. As I mentioned, we use hydrocarbon gases and we explode them. So we actually use acetylene and oxygen. We ignite this with a spark from an electrode. And in that 1 millisecond, we get gram amounts of graphene. We have scaled this up to produce in 1 2x2 meter footprint, 10 metric tons of graphene per year. This is very high quality graphene at 99.8% pure. It is 100% crystalline, 100% sp2 bonded graphene, which for any nerd out there is very important. And most importantly, we use virtually no energy in this process. Acetylene is a very volatile gas. It brings a lot of energy with it. So effectively, we are unlocking that energy that is in the acetylene to power the entire process. And because of this simplicity as well, we don't have any waste. So we're extremely eco-friendly, and the resulting graphene is of very, very high quality. So this is a little graph just to show some of the differences. Of course, our energy use is very small. We don't use chemicals or solutions as part of the process. There are no greenhouse gas emissions. The energy use is very, very low. But beyond this, once we get the graphene, we can further improve our carbon footprint by improving the materials that we're using graphene in. Concrete is a very popular story. I think most graphene companies talk about this. For every 450 kilos, or it reduces 450 kilos of carbon dioxide per ton of carbon produced, and roughly 2 billion tons of concrete is produced annually. By using graphene in 1% of the total concrete production, we would be able to significantly reduce CO2 emissions. And this would be equivalent, roughly so, of taking 2.7 million cars off the road each year. Of course, we also have our data on lubricants. We can increase the life of lubricants by 24 times. That would enable less disposal. There's going to be better heat transfer. Machines will operate better. So with every material that we're improving, we can look at lots of immediate benefits with the less material being used. So that would have its own carbon offset, and lots of secondary benefits. Everything that we have is patented. If you look at the patent for fractal graphene production, this has been patented back in 2016. We also have reactive graphene, which is our functionalized graphene. We have many different types: graphene ink, graphene enhanced carbon fiber, and a patent on hydrogen production, which is very different from our graphene production, but is a low-cost way to produce hydrogen also from hydrocarbon gases. So we are partnered not only with the GEEK, but also with Khalifa University, and we are a verified graphene producer. This is a high standard for the industry. It is an independent third-party test. I'm sure many other, or a few other, there's only 5 of us, companies will share the same news. We're very happy with this, and we do think that as this industry grows, this is a very important factor in creating a trusting system where customers know what they're getting. It is the same graphene every time, and to now create these standards in the industry, we believe is of the utmost importance. So running on the end of our time that we have available, but just to touch on a few last points, we are very high performing. We have consistent results. We have a very green footprint. We have global reach if we're looking at the industries that this technology can touch. We have strong economics, and there's, because we are undervalued, significant valuation upside. So we are going to be arranging our last round of funding roughly end of May, beginning of June. We would like to be raising about 5 million US. This would be the last time that the company would need to raise any additional funds. So this is an exciting moment for us. We do believe this is the year that this is really going to take off. So of course you can see just on the right here our basic cap structure, but importantly, if anyone is interested in learning more, please reach out to me and we can always have a conversation.
Excellent, Kirsten.
Thank you.
And we're just on time. So thank you again, and thanks for the shout out about the verification program. It is, I agree, I think it's important.
For more information on market opportunities and to connect with experts, contact the Graphene Council at thegrathenecouncil.org.